Okay, so we're going to jump right into Pixinsight here where I've opened it up and I just want to give you an idea of what we're trying to accomplish tonight. So here's a picture of Andromeda that I've taken back in July, and as you can see here, it's not too bad. This is a 20-second sub at ISO 8000, and this is a 5-minute sub at ISO 800. Back then I was trying to figure out which one worked better, but I figured out that I can probably use both sets of data. And my goal out of this, if I close these, is to get to this. This is what I originally processed. It's quite good. However, I went over processed the stars a little bit. I'm not as happy as I'd like to be over the whole thing. And you might notice that it's been cropped in a little bit more than I would have preferred. And partly this is because when I was doing it, I ended up doing it on an angle, and I cropped it down to be able to do some steps a little bit faster, but ultimately I ended up basically cutting it right here and right here, and I'd like to basically redo this with a bigger crop. And I thought, well, if I'm going to have to redo this, I might as well take a video and show you guys sort of the steps I was going through in order to get this. So this is the goal. So let's grab some data and do a stack. I don't think I even have darks. I have stuff on the other screen here. I'm using two monitors. But basically all I'm doing is going over and finding the data over here, which is a bunch of NEFs. And I have the data here. Okay, so I have the old data here. There's a bunch of different subs. I'm going to basically have it where, like these ones here, if I just pull it up here for a second. You can see there's data here. I had it a different orientation. I'm just going to basically register them all together. Since I've done this before, I know that I can actually do that. You'll notice I don't have any flats, I don't have any darks, nothing like that. Back then I wasn't actually taking those, so yeah. Make sure you take your, so normally the first one's an image calibration, but instead we're going to do a star line. And basically what I'm going to do is, I don't need this one, so we can delete that. Yeah, I don't need it. I'm going to take all this data and I'm going to drop it into Pixinsight into my star alignment, which is going to go there. And I'm going to pick one of these, probably the 20-second one. Whoops, I didn't really want to open that, but okay. And all I'm doing is quickly saying, yeah, looks like the stars are round. Good. So we can actually close that off for now. And we're going to drag that one up here to the reference image, and we're going to close it. Now there's stuff that you can do like drizzle data and stuff. I haven't quite figured out exactly how to do that yet, so we're going to skip it. It's going to create my output in the same directory, and it's going to add a post fixture called -r. And the ideal situation here is that it's going to also create these as XIF files, which is going to allow me to notice which ones are which, but it's basically a 32-bit enclosure. So we're just going to hold on here for a second and yeah, just sort of wait. This takes a few minutes, even with my computer, so play some music. Okay, so I just learned that running a capture program and Pixinsight at the same time, I had Photoshop open, so I closed that down because that also uses up quite a bit of space. But by doing that, we've ended up with all these light frames. So by going to View and Group by Type, here's all 59 of our images. And the next step in the process is one that's called, and I never have it open because I'm awful, it's called Blink. Okay. And the reason we want to run Blink is we want to make sure all our frames look good together. Okay. So here we go. And yes, as you can see, as I said before, some of the images were rotated 45-degree angle because I took them on an earlier night. But overall, the goal here, and we go frame by frame, is to make sure they all look like they're sharp, there's no squiggles, and the stars don't move. And of course, we're going to have some that have satellites, but overall we just want to make sure there's nothing too crazy. I don't mind 1 or 2 satellites in the photo. It's actually pretty solvable later. Oh, that's not terribly great. Now, one thing we can do is do this. What this does is it's going to try to correct for the images. So get them all about the same level of screen transfer. This means that we can then look at them and see if there's any that are like really blown out, maybe a cloud went in front of them, and we'd remove those from there. It's going to make them look green and some other funny colors. Don't worry about that at this point. Oh, you can also hit play, which is going to run through them. So that's sort of what we end up with. All this data looks good. I know this because I actually went through earlier and I did nick 1 or 2 frames from the original batch. Generally, when I find a frame that's no good, my general position is delete it, and that way you don't accidentally add it into the stack by accident and have to go through this. So there's a couple frames I'm not super happy with the meteor strikes going through. So I'm going to see if I can find those. So this one here I'm not happy with. It's just too close to the data that I want. This one here I have less concern over. So this one here is there. So we're going to find that one. 811. Go here. There's a couple ways of doing this that I'm sure people will have a great time telling you all about. But since it's just one here, I'm just going to delete it. And it's gone. And the rest of the frames I'm pretty happy with, despite the fact there are a couple little mirror strikes. But that's just simply too close. So we're going to close that, and we're going to move to the integration stage. So this is where we stack the photos. Now, we grab all of them here, like so, and we drag them over. Now there are some settings here. I generally use the same settings for almost every single photo. At some point I will improve this, but for right now I'm using average, additive scaling. I'm using the integrated K-sigma bi-weighted mid-variance. This one here seems to work well when you have a lot of data, so I'm happy with that. The pixel rejections here, I don't really have them. Maybe go like this. Here we go. There's some settings here. Most of these are like default settings. Not going to worry about it too much. I'm sure somebody at this point is going to tell you that you should do an RGB split, which I haven't actually learned how to do yet. So take this tutorial with a grain of salt. That this is my current process. I'm obviously adding new steps as I go. As you can sort of see here, I've added a couple new steps in there, but we'll hit the integration and it'll take a few minutes to integrate. Again, with the video recording, it's going to take a lot longer than normally, but that's what you sort of get when you're trying to do a video at the same time as run Pixinsight, which is CPU intensive. I think I can pull over here. So you can see here it's pretty CPU intensive and it uses a lot of RAM. I have quite a bit of RAM, so I'm not worried about overstripping the RAM, but obviously if you have a slower computer, this is going to take more time. Pixinsight will generally eat about 80% of your CPU power, and that leaves a couple other things. But like I have like my Logic Cam here running, I have the Streamlabs OBS running. Those normally don't run, and I can generally get a little bit more out of Pixinsight. But for the purpose of this video, that's what I got. And as you can see here, it's using 12 working threads because I have a 12-core machine, and it will run through it, and eventually the data will start to come through. There we go. And it'll do this in cycle batches to go through all the photos in the batch. And now it's just basically a waiting game. This is the part where I pull up my phone normally and I Google things on the internet while I wait for this to happen. And how are we doing here? Oh, we're still going. Okay, and then this is what we end up as the output. Close that off. So we have the rejection, which, as you see here, is not going to reject too much other than the fact that there are some framing issues. And this is what we ended up wanting to get. And boom, there's our integrated, and yeah, we have a couple little things we need to work out. But yeah, so there's our integrated galaxy. So one of the things we're going to do here quickly is here, and we're just going to call this the we're going to do it the right way and actually save as. We want to save it as the XISF format. Just come there, and we're just going to call this first integration. And this is just so that we can go back here and play with the data from this point if we need to. Take 2 seconds to save. Okay, so the next step that we generally want to do is crop. And the reason we want to crop early is because this saves us a lot of processing time not having to go after this again and again. Now for this image here, what I would like to do is actually crop it in the proper format this time, an orientation that everyone seems to like, rather than have it sort of processed the other way and then doing it later. So by doing that, there we go. And this is the orientation that most people see this galaxy at. I personally like to do it the other way, but I've had people comment that visually this is what they enjoy far, far more. Next thing I'm going to do is background neutralization. And basically I want to pick a known dark spot where there's no stars. And just scroll all the way down here. It's a good spot. We want to go mode, a new preview, and we're just going to find a section here that doesn't have any stars, like so. And then we're going to say the target image here is that preview. And we hit this button here, and it's going to do that. But if we zoom out here, you'll see that we have to run the screen transfer function again. And there we go. Now we have the galaxy in a more even color. It's going to end up being here. You can still see there's some color in it. We're going to pull that out later, but it gets rid of all that nasty color grading that we had. The next step that we have that we can do if we end up having too much is we can run this, get rid of the greens, the reds, or the blues. But as this is pretty color neutral already, we don't really need to do that step for this. However, if you do have a camera, older cameras tend to have a lot of green. This is generally a good process to run through, and you just open it up, you run it like that, and it's done. In this picture, it's not going to do very much, but it is there as an option. We then have background removal tools. Now there's dynamic background removal, and there's automatic background removal. To give you an idea, I'm going to run this one first, and it's just simply because it's automatic, it goes pretty quick, and it's going to produce this. You stretch it, looks like that, and the background that it removed is that, which is pretty close to what we actually have. But if we open this up again in 1 second, you'll note here that you end up with this big dark halo around your objects, which is really not what we want, and it really likes the donut. And again, part of the reason is because we didn't do flats, or I didn't do flats, that this would be less of a problem. So actually it's better to do dynamic background extraction than go through and basically using the indicator indicate where should it be black. So you definitely don't want to put any on the object itself, you don't want to put any right here, and you don't want to put any on this other little galaxy, but you generally want to go around the edges here a little bit in to try to get that set up. So I'm going to go do that right now, and I will show you what we end up with. Okay, so we're just going to zoom in here and start adding points. I generally recommend starting at one corner you think is the worst, and you want to sort of do this. It is important that you don't get any stars, so something like this doesn't work. You can sort of see here in the top corner where that's showing you that that's too bright. So you don't want to move it over. And how many points you do is up to you. There's a certain point where it gets a little excessive, but you're generally trying to put it where you can get the gradient in there, because all you're trying to do is tell the computer this should be background, and all these background points that you're picking should have the same brightness once you've gone through and processed everything. Now, since I don't do darks or flats, I do occasionally end up with these little streaks here of blue and red, and that's not ideal, but there is a way of getting rid of them later in the process, so I don't tend to worry too much about them. Sometimes it's good to zoom out and zoom in just to make sure you know where you are, because again, you do not want to put points that are too close to your DSO. You see another little small object here. Okay, so there we have it, where we've added a bunch of points. Obviously we could add more, but that's enough. We're going to want to go down here, we're going to click subtraction, and we're going to click that. And we'll allow it to run, and it'll produce a background like so, which we can put up here. And it's going to produce an image like so. There we go. Shrink that down for a second here. Go. So we don't need this integration just here for now. And to give you an idea, that's the two masks that we got. This is automatic, and this is using our dynamic. And as you can see, the automatic tends to create this circle here. It created that halo around it, whereas the dynamic is a little bit more even. And again, if we had used flats, if we'd used darks, we probably could have gotten away with the automatic background extraction, but for now, we had to go with the dynamic, and we end up with this dynamic. We don't actually need these, so we're going to delete those. And again, since this is another step, I'm going to hit Save As, and I'm just going to save the integration. Okay, so the next step people will do is a little bit of noise reduction, a little bit of starlet transformation. And if we pull this up here, although this preview window doesn't always do the best, because you can't zoom in on the preview window. Oh, you can. Huh. Okay. I did not know you could do that. So it sort of shows you what you're doing. And basically here you're trying to remove some of the noise. Now, I don't tend to use this feature that much, mainly because I find that it tends to cause other issues. But it is there for people who want to use it, and probably a sigma noise threshold. Yeah, the sigma noise threshold is a little bit interesting. And you can sort of see the spinning wheel here. So we can do that and go like that. There we go. So that's our image so far. And the next step is to actually stretch the image. Here, it's a mask stretch. Again, these settings were set up earlier. They seem to work almost all the time. You can add a background reference if you want. I generally find that this just works. Without one, we can stretch. Now, this is going to take quite a long time. So for right now, I'm going to wait and see how things go, because I suspect my voice is probably going jibber joop. Okay, so this gives us our stretched integration. Obviously, we have to run the screen transfer function to push it back, and that gives us our galaxy, and it's pretty nice. There's a little bit of red out here in this edge here, and a little bit over here, but it's not too bad. But otherwise, yeah, there's our galaxy, and if we zoom in, ooh, look at the lovely, lovely galaxy. So again, since this was a big step that took, how long? It took just short of 6 minutes to do this stretch. So we're going to hit Save As again. And we'll save it. And again, we're saving it a lot of times just simply so we can do stuff. Now, there's a couple new processes that we can use. We can create a star mask. There is this one here, and I believe 32 is the setting. And we're going to give this a go. StarNet++. Now, normally I don't do it inside Pixinsight, but I've been told it does work. However, it's going to basically lock up Pixinsight until it's done, and we're basically just waiting for it. Sort of a reality, but let's see if this works, and hopefully I set 32 as the right number, or I could be sitting here for a very long time and or have to restart Pixinsight. But by doing it inside Pixinsight, I don't have to do a couple extra steps, which is a bit of a pain, but I will cover that at a later point in another video when I show you how to do this outside of Pixinsight. So this is why I don't normally use StarNet as an internal thing. It's a beta, it sometimes doesn't work, and it's been now several minutes and it's crashed, and it might eventually kick out something, but for right now it's toast. So I'm going to cancel out of this, which is why it's important I saved the data before. Okay, and we're back here, and I've rebooted Pixinsight. I figured out that running it at stride 128 is what I need to do. By running it the other way, it just sort of went a little bit nuts. Okay, so I've ended up with the stretched mask here, which is a starless mask and a starred mask. So I ended up using the internal one now that I figured out what I was supposed to do. I'm going to save as, and we're going to call this one Starless. Overwrite the 132-bit. And gives you an idea, this is at 64, and this is at 128. And close that one, we don't need it. So this one here, you can clearly see here I've got a spot right here, another one right here, a bit of a stretch here, and there's a couple little spots where obviously I've had little dust centers. Again, doing a flat would have helped with that, and I also ended up with a star mask by basically clicking this button here and just running the process twice. And that gives me that. Both of these are stretched images. Okay, so now that I have the starless mask, I'm going to start doing some color correction. I have histogram transformation and curves transformation. Both of these allow for an image, and I just want to make sure I'm on the stretch and stretch too. So I want to be on stretch, like so. We can turn this here, and basically we can go and we can stretch the image. Now we don't want to necessarily blow out any of the stars, but we definitely want to try to get the image stretched as much as possible, which we can run there, and like so. And we definitely want to come over here, and this is where we can play with things like increasing the saturation. Again, I'm going to press this button here, and we're on here. I don't tend to worry about saturation being blown out outside the core. That can be sort of solved a little bit later, but we can do that. You can try to add a little bit of color in here. Obviously, if you take this and you go too far, it starts falling apart. So these are just subtle changes just to try to get a little bit more color out of the image, like so. And you can do this a couple ways, but basically it's very slight, and all you're trying to do is pull out the color you want. A little bit more. You can also do like luminance here. And again, we have the star mask that's going to come in. So mainly we're interested in trying to maximize this area here and not so much worry about the outside, because that we can basically crush in post later. And apply it here. There we go. And which was this one? No, we don't want to do that. And here we go. So open this one here. And there's generally a number somewhere around here it ends up being happy. Obviously, if you start throwing really crazy numbers, it totally falls apart. I generally find that setting the contrast limit to about 1 or 0.1 or 2 generally does enough, and then it's more playing with the kernel radius that allows you to sort of pull out that color. Go. Clearly we want a little bit higher resolution. Go. And I do find that this preview does not actually end up really accurately showing you what you want. So you do have to like sort of run it and see what you end up getting. And that gets us sort of here where we're starting to see the layers. Now we could run it again. Not sure how that well will look. It might actually end up pushing this a bit too far. So we'll give it a try, but I suspect this is probably a bit of overkill. Yeah, and as you can see, I pushed it way too far. That just doesn't look natural at all. So we're going to pull it back a bit and go back here to this, and we're going to play a little bit with the saturation. See if we can maybe get it a little bit better. Okay, so we've gotten to this point here, which I think is pretty good. What I'm trying to do right now is kill the... Yeah, so that's not going to work. Oh, I have to stop hitting Control-Z. Okay, so we're going to put that back here slightly, and we're going to go back to this one here and see how badly I can sort of crush this while still getting some colors in the actual thing. All right. There we go. So this is saturation, this is hue, this is ABC coloring, this is luminance. We can go here to the K factor and play around with this. I generally will pull the K factor down a bit in this, because again, I don't really need all this extra data out here. I have the star mask, it's going to come in. Basically, I'm trying to focus mainly on this and trying to pull it out. So we're going to do that, which is going to give us, yeah, this image here, which we can then go to this, and we want to pick here the stretch, not the star mask. And we probably want to move it just ever so slightly here. Again, pull this up and boost the center a little bit. We are throwing, by doing this, we are throwing a little data out the window, but for the sake of getting a little bit more contrast in there, again, we could go down here and get sort of this thing. This is actually not too bad. Oops. Yeah, you definitely don't want to do that. And again, we're just making minor corrections and applying them to the image, and then looking at what we have in the image and then deciding, is that really what we want? And overall, this is, I think, pretty good. I'm going to play around a little bit more with saturation and put the preview on. Go. And for hue, again, I'm tempted to try I don't want to push it too extreme here or here, but what I'm trying to do, is get it so I get a little bit more color out, but it's not just all yellow. So that's where we're going here. There we go. And again, this is more art than science steps, but you can end up with something like this. That's not too bad. On here, we zoom in here. My general comment on this one here, and we'll reset this and pull it up, see it here, is maybe bop up the saturation just a little bit. Not a huge amount. And we're going to pop over here. And yeah, so you can see here that we have red and blue, green stars. You can always do this. It's going to pull it up. You can sort of make the stars brighter and brighter. Generally, with stars, you want them enough that they're there. So I generally would suggest leaving this one here. And that gets you to sort of this step here. We'll close the preview. So you have this star mask here, and you have your star mask is right here, and your starless is integrated. Now there's a couple of different ways to integrate this in Pixinsight, but generally what I do at this point is I say, okay, I now want to make sure that this And that's the issue. Like, you can't really stretch it like that because it ends up going a little crazy. But you can take that, and what you want to do now is save as, and what we're going to do is actually save them as JPEGs. And we save them like that. Save. Yeah, it's going to be upset. That's okay. Set that to 100. Yeah. It gives you several warnings which are like, hey, this doesn't have enough data, because you're basically going from 32-bit down to an 8-bit. Which, if you know Pixinsight better than I do, you don't have to do. There's ways of doing it all inside Pixinsight, but I don't know that well, so I'm going to go with this and show you what I'm doing. Yes, hit yes, 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 100%. Okay, so we're going to open Photoshop, and we're going to go here, and we're going to find those JPEGs, which are right here and here, the two JPEGs, which are now in 8-bit. You can pull them over as TIFFs in 16 or 32-bit, but a lot of the Photoshop tasks don't do very well if you're not in an 8-bit color space, and I'd rather Pixinsight does the compression down to 8-bit than in Photoshop, because I find that Pixinsight does a better job. And we'll load these up, and you get two images. So the first thing I'm going to do is take this image, and I'm going to plop it on top of this image, and I'm going to go screen. I can also pick lighten, and the difference, lighten screen. So screen, I think, is better. There's a bunch of other stuff you can do, like linear dodge add. Particular picture that you're using, you may want to pick one or the other. And again, this is again a bit of an art thing. And if you find that you're like, okay, so I like this one a little bit more, and the stars are a bit bright, so we can go like 50% or 75% or whatever you want to do to get that in the background. So we're going to do that, and we can zoom in here and we can see, okay, so maybe not so great. You know what? Actually, both of them. So we're just going to leave it as one's linear dodge, one screen. So here's an Andromeda galaxy. It's there. Again, we have the background layer here that we're going to mainly play with behind the stars. So we can go here to like camera raw filter. I like using camera raw filter. People who use Lightroom are very familiar with it, and you have this up. Now, what I'm trying to do here in camera raw filter. So we're here and we're just changing some settings. Mainly what I like to do here is I'm going to reduce some of the blue. I can reduce some of the blue luminance. I can increase it. I can play around with it. But more importantly, I can go here, reduce the saturation a bit. I don't necessarily want it as blue. I can adjust the hue a little bit. Again, we're being a little artistic here. And yellow, I maybe want to go a little bit more orange and get sort of that. And we're going to hit OK on this. I'm not going to play too much with the luminances. A little bit more yellow. Oh, it's that one, the orange. Okay. And that's going to give us this. Again, it doesn't do a lot, but it just adds a little bit more definition in the galaxy without going too crazy. Because if we want to, we can always do something insane like this. Go to this curve here and go whoop. You know, really brighten it up. Go back here and be like, well, I want the blacks crushed. Like, you can really go a little crazy on this and create sort of this, but then you're really playing around with the data. That's a little bit more than you can pull and adjust. Other setting here you can do, if you don't like using camera raw setting, you can do it this way. Although, again, I really feel you're starting to play with data, and you have to remember that you've already crushed it from 32-bit down to 16-bit. So it sort of gets you to where you are. And this is sort of where we are at now. Now, I'm trying to remember what I did for this setting here, but we have this. So it's not too bad. So we're going to hit Save As with this. I'm going to show you sort of a different way of doing this. I'm going to just go here. Step 1. Okay. All right, and there you go. There's the Andromeda Galaxy sort of there. We're going to close this. We still have this guy here. We're just going to go back here and find our Starless map and put it here. Drop. Okay. Drop it beneath it. We said we wanted it as a color dodge add, and we wanted to duplicate the layer. Not delete. Duplicate the layer. There we go. And we're going to pick this one as screen just to give us a bit more stars. And here we're actually going to go to some filters, and it's called Topaz. And what you can actually do is denoise the image. Now we're denoising the background. I haven't purchased Topaz yet. I'm running it off of the trial version. As you can see here, I have 19 days left. It's sort of an interesting thing to do because you can sort of remove noise in your image and increase the sharpening. Like generally you can like really push it crazy depending on what you want to do. However, you're going to notice here that while you're getting sharpness here versus here, you do lose it in other areas. So that's something to consider when you're doing this. So the other Topaz tool that you have is Sharpen AI. And this one here is sort of a neat one. Sometimes it works, sometimes it doesn't. As we wait. There we go. So you can sort of see here, we're sharpening up our detail. Now there's a couple different ways of doing it. I'm going to pick focus, because that's really what we're trying to do, is just get a little bit better focus, because it should go. And again, it runs pretty good, but it does take a bit of processing, and you do need to be pretty light on these controls, because otherwise you get a lot of the AI thinks it's sort of doing one thing and you're like, no. The other one is stabilize. Let's see. And again, for each picture, it depends on what you're trying to do, what you're trying to get, and I find that there's no real fixed way of doing this. So you're going from this to this. Like it's not a huge improvement, but you can definitely see from one side to the other, that's sort of there. And if you want to, maybe in this one I can increase the noise suppression, but it's going to start doing some weird stuff. So you're going from there to there. Actually, that worked out pretty well. Ignore what I said earlier. That seems to work better for this photo. It's also important that you come out here to the darker spots, because that is part of your image, and the processing step is going to do something a little different. So we still have these little spots here that we have to deal with, but there's a particular tool in Photoshop that does it, and I will have the scientific people screaming in horror when I show you what tool to use. And I apologize in advance to all those who are going to scream in horror for the next tool once this is done. So yeah, so this is Topaz Sharpen. I suspect I'm going to end up buying it at the end of the trial period. It actually does work quite well, and the denoise actually works exceedingly well as well. And it works okay for astrophotography, but oh my goodness, terrestrial photography, it's like, oh, this was in focus and it wasn't. Now let's just fix it. So now we're going to hop over to Topaz Denoise. And the only reason why we're doing this is to see if we can squeak out a little bit more, because obviously one is a denoising program, the other one's not. And as I said, we're trying to keep the detail here while doing it over there. So we're going to go AI clear auto. Let's see what it does. Yeah, it's not really, unless I can punch up some chroma. Yeah, let's go there. I don't want to sharpen at this point. I've done my sharpening. Yeah, again, it's starting to blow out a lot of the detail. Of course, somebody could say, well, just do this. And you can do this. See what this actually looks like. Just as an example to show people what ends up happening when you push everything to maximum. You basically end up getting more or less the same image. there's a little, actually there's a little bit of noise reduction here. Let's go 40%, 60, 75. Yeah, you know what? That's actually a pretty decent improvement. Yeah, let's save that, and well, let's see if we can do chroma. Yeah, cool. And again, it's important to do this on the starless mask, because if you do this with stars, the stars just go kablooey, because it assumes that the stars is either being overly sharpened, under sharpened, etc. And at the end of the day, what you're really trying to do is get the stuff beneath it to be a little bit better. And that's what we end up with right now. Can I do that? Okay. And yeah. Oh right, I was going to show people how to do this. Okay, so yeah, that's the other thing too, is it creates these weird square effects. So when you do it like this, you don't see it, but go like this, it does create this weird square effect here. I'm not sure exactly why that is. It is the Topaz AI, I believe, doing it, or the StarNet, one of the two. It's a little annoying, but as you can see, there's really no background detail in this. So this is, again, the people screaming in horror as I go and ratify this layer. There we go. And I sit there and say, okay, well, is that a star or is it a smudge? Well, let's find out. And you can do this, like, and try to deal with that issue. But more importantly, what I'm just trying to go around here to find is any weird artifacts. But yeah, so this is an interesting artifact. You can just go like this, and this will basically solve most of it. There's other things you can do. I know it's not perfect. It's kind of a weird setting to have. But again, in Photoshop, you can sort of just go along here and fix things, and I'm not really even worried about that kind of detail because my star mask is there. So, and it covers most of the stuff. There we go. So we have our star mask here. Now, things that we are going to notice, because people like to zoom in on these pictures, is things like that, where we've got our streaking. And the trick to that is, and it's a little time consuming, so I'm probably going to fast forward the video through this, but ta-da, it's gone. Ta-da, it's gone type thing. Zoom out enough that you can actually see it. And basically we're just going through with the brush, and it will get rid of these little artifacts for us that are all over the place. And I may accidentally nick a star here or there. It's not the end of the world. My main thing here is just get rid of any clearly red or blue streaking that is not a star. And again, we have them going in two different directions here because I had if you remember back to the initial image, I had them going in 45-degree angles. So I do have some star issues. There we go. Okay, so this is what we finally ended up with. Now, this is a little different if I go here to what we had before, which was far more yellow and definitely a little bit more erratic in the colors. I've knocked a lot of the blue out of the image, and I went very yellow. So we're going to try something a little bit different here, but I still want the blue saturations to definitely drop a bit because they're a little extreme, and the purples come down. But what I want to do is move most of the purples into the blue. And best to zoom out. Yeah, see, we end up with a lot of blue here. So if we can go saturation, blues can go down a little bit, but more importantly, we can drop the blue luminance. There. Okay, and we'll boost the yellows and the oranges. Saturation on the blues and yellows. Greens again, I don't really want too much green. Greens I'll probably push towards yellow. Yellows are good. Orange. See, here's where we can sort of play with the core since it's sort of a yellow. So we're going to go with yellow core. Go there. Okay, I'm going to zoom back out. And again, see, we have a very yellow and a blue here that's different. So we do want to see if we can get the blue a little bit happier, although I don't want to go too crazy, because I am playing with them a bit. And yeah, this is again very subjective to Topaz Denoise. Now we're denoising the entire thing. I don't know if this is actually something that you're going to want to do, but as I'm trying to like reproduce the image I made earlier, which I forgot to save the steps on. Again, we might be pushing the image a bit too much here. And I don't know why the split works differently in both of them. I like this a little bit more. You can really sort of see what you're doing. And there we go. And yeah, so what I'm doing here is, again, I'm going through and I'm removing the stars. And the reason I'm doing this is because I'm not planning on doing a huge amount of processing or anything like that. All I want to do at this point is just try to drop the star level without having to affect the background galaxy color. Okay, so here we go. We have the Starless here. We're gonna grab this, bring it over here, and we're gonna drop it on here, and we're gonna make it 25%. There we go. So had it really bright. It's bringing down the stars a bit. Maybe we'll go 50%. So there you go. So now you have the stars that aren't completely blown out of proportion. And if you're like, oh, but I do want this, you can go to your adjustment layer here, and you can bring back those stars a bit, but now you're bringing up the galaxy with it, or more appropriately, something like this. And yeah, I think at this point, I'm going to hit Save As. I'm going to go and say, I want to save this as a JPEG. Actually, you know what? I'm going to use the Export tool at this point. And then, because I want to actually output it to the internet, and this is a relatively large file, I'm going to sit here and go like this. I generally output the internet at 800 by whatever. It tends to work pretty well. And I generally want big cubic smoother. And the reason I'm picking smoother is because while sharpness is good for stars and stuff, I find that if you shrink it down and you put sharpening in, it ends up basically just going a little nuts, and you end up with like point sources. So we're going to go like that. And we're going to go like this. And we're going to go final underscore web. So, assuming that's going to work. There we go. Save. And ta-da. And this is what we end up as the final image. And I think this is pretty good for an hour and a half. And again, I'm trying new processing techniques every day I'm doing this, and I hope to come out with a better and better image as I work along. But it gives us pretty good detail, there's not too much noise, and overall I'm quite happy. So one final note about this photo was that I liked it, but when I originally had the other version I made and I didn't write down all the steps, it actually ended up having a lot more nebulosity in there, and the lanes weren't necessarily as defined, but it was a little bit cleaner. So I've gone and basically pulled in the original integration, and this is basically just, it's been integrated and it's been stretched from before, and I'm just making a couple little changes in the smart filters to sort of increase the contrast a little bit closer to what I had, and then I'm adjusting the luminosity, so now the background color is now in there, and we press this here. I duplicated the back layer and I put the back layer over top, and then I've gone and so this is what I originally had as a finished completion, and by using the overlay, I'm actually able to bring out a little bit more data. I'm pulling up these curves here, adjusting downward, and I'm saying, there we go. That looks a lot nicer, it's cleaner, and you have a lot more gradient drop off from the black background to Andromeda. And that, I think, is going to be the final result after I thought about the final result yesterday when I finished and looked at it and said, I think I could pull a little bit more out, which is why it's important to save your steps as you go, because sometimes you do something and you get detail in one spot, but you lose another, and by recombining the images at the end, you can pull back some of that detail that you lost. and adjustments that you made that slightly improved it. And again, I could continue to do this for a significant amount of time to keep pulling out that little bit of extra data, but at this point, that's a pretty good end result, and I'm quite happy with it actually, and this is what I'll be sharing as my final image. I hope you enjoyed going through that video with me. It was a lot of work on a weekend to come up with a photo like that. And part of the reason I did this video was to show people that it's not just a 5-minute processing step. It's not just I stretched it and magically I got this data out of it with a couple little curves. There's actually a lot of work that goes into astrophotography post-processing, almost more so than the actual time it took to get the photo. So I hope you appreciate this video and you consider giving me a like. Perhaps if you want to see more types of this astrovlog videos, subscribe. And if you have any questions, comments, critiques, just leave them in the comments below, because that will help guide me where I should be making future videos so I'm able to help you improve your astrophotography. And thank you for watching.